Hey everyone. So this is what I'm going to refer to as Algebra Challenge number 3. And what you're going to be doing is learning how to solve for variables in this case. We've already talked about solving for variables when you have a variable on one side of the equation. So I'm going to take a little time to review that and then teach you how to solve if you've got variables on both sides of the equation. You can see I've included a picture of a scale here, and the scale is balanced. I'm going to be referring to the idea of a scale and keeping a scale balanced throughout this video, so that's why I included it there. I think about it as balanced, and we're balancing equations. It's all about keeping things equal. All right, you can also see I've included a picture using algebra tiles. I'd like you to just think about the algebra tiles as a model of what's happening. I really want you to focus more on this right here in terms of actually solving for variables, but I'll be referring to this as a picture of what's going on. So you can see our first problem is 7x minus 2 equals 19. Here's how you would represent that on the algebra tiles. 7 x's and 2 negatives, or 7x minus 2 equals 19. Again, think about this as both sides of the scale, and think about the equal sign as the middle of the scale, or where the balance would be. All right, so this side of the equation, 7x minus 2, is equal to 19. You could also think about it like weight. Right, so if this is one side of the scale, these 7 x's and 2 negatives weigh the same as these 19 positives. Right, the idea when we're solving is to keep everything balanced. So you're going to hear me say this over and over again. What we do to one side, we want to do to the other side, and that's to keep everything the same weight or balanced. Right, so when we're solving for variables, what we want to do is isolate the variable. That means we want to leave it by itself. So everything that's on the same side of the equation with the variable needs to go away. So I had another co-teacher of mine tell me once that when she talked about this with her students, she talks about this as undoing the problem so that you're left just with the variable. And if you think about it like that, that's kind of cool. So by undoing, we mean you're going to think opposites. So you've got a subtraction problem, you're going to undo it by adding. The other thing that happens when you're undoing a problem is you're really doing the order of operations backwards. All right, so basically, you want to do any adding and subtracting first in this case. Another way I put it is you want to save your coefficient for last, or save your division step for last. So get rid of any numbers that are by themselves or without the variable first. All right, so you can see I added 2 to both sides, leaving me with 7x equals 21. Okay, in terms of algebra tiles, basically, picture of that, I added 2 to both sides. I added 2 here, and I added 2 here. Then what I have here is some zero pairs. So I'm left with 7x here and 21 here. Again, think about this as just a picture of what happened here. Okay, so then my last step here is the division step. So I'm going to divide by 7 because I want to be left with 1x, and 7 divided by 7 is 1. Right, 21 divided by 7 is 3. So as long as you do the same thing to both sides, it stays equal. Over here with the algebra tiles, you can see really nothing changes between the two except for the way everything is arranged. Think about this. If these 7 bars are the same weight as 21 units, then how much does each x bar have to weigh? Right? They're all equal. All right, so we just divided them up evenly, and you can see each x bar is equal to 3. Again, just a picture of what happened here. Right, so let's move on to a situation where you've got variables on both sides. The only thing that happens here that's different is we're going to get the variables onto one side first, and then we'll solve it just like we have the others. All right, so what I want to start with is I want to get this 2x off this side, but I have to make sure I'm doing the same thing to both sides of the equation. Right, so I subtracted 2x from this side, I'm going to subtract 2x from this side. Note in this case, I'm subtracting the entire term, not just the 2. I'm getting rid of the entire term, so I have to do the same thing here. Right, what that looks like over here is I'm adding 2 negative x bars to both sides, so 2 here and 2 here. Right, and then I can basically get rid of the 0 pairs. Right, so I'd be left with 2 x's, and then plus 3 equals -1. But note, this is combining like terms. Right, we talked about combining like terms as apples and bananas or something like that. Well, if we had 4 apples and we subtracted 2 apples, we're still left with 2 apples. So if we have 4 x's and we're subtracting 2 x's, we're still left with 2 x's. The x itself doesn't change. All right, I'm hoping that makes sense to you. All right, and then from here, we're just going to do what we did before. All right, so I'm going to add 3 to both sides. All right, I added 3 to both sides. Excuse me, I'm adding -3 to both sides or subtracting 3. So adding -3 would make these all 0 pairs, and then I'd be left with -4 over here. So I'm left with 2x equals -4. You can see when I divide it, I'm left with x equals -2. But note from here on, it's just the same process we used to solve when we have the variable on one side. So the only thing you have to do if you have variables on both sides is just get them on one side first. All right, so we're going to try a few on our own right now, and because I'm typing, I'm not going to actually do all of this written out, so I just want you to listen to my thinking. So in this case, our variable is m, and we want to leave the m by itself. Right, so the first thing I'm going to do is subtract 1 from both sides. Right, so when I do that, that leaves me with 2m, which is what I want to be left with, equals 38. Right, and then I'm going to divide both sides by 2. Right, so if I divide the first side by 2, that leaves me with m. And then if I do 38 divided by 2, that leaves me with 19. All right, so m equals 19. All right, one thing I didn't talk about is checking your work. All right, so this is an easy one to check. Let's say, did I get that right? Is m equal to 19? Well, just plug the 19 in here and see if it works. All right, so 2 times 19, that's 38, plus 1 is 39. Sure enough, we did it correctly. You can see in your check some of the same numbers should show up. If they don't, you might want to go back and double check. All right, let's try another one. All right, let's try this one. This time we have variables on both sides of the equation. I'm going to try to do this. I'm going to get this 3y off this side. By the way, I could get the 8y off this side, but I like to be left with positives. I'm going to show you in the next slide, and I think you can see by looking at it, I'm going to show you how to do it 2 ways and show you that either way you do it, you end up with the same answer. Okay, so again, I'm doing some of this in my head. So I'd be left with 5y minus 7 equals 18. All right, now I'm back to one variable. All right, so I want to get rid of the -7 first. So then I would have 5y. All right, I'm going to add 7 to both sides. So that would be equals 18 plus 7 is 25. Right. And then I'm going to divide both sides by 5. So I'd be left with y equals 5. All right, and then just to double check that real quick, this would end up being 40 minus 7. So 40 minus 7, that's going to be 33, is equal to, this would be 15 plus 18, and 15 plus 18 is 33. All right, so we have 33 on both sides. So checking it lets me know, yeah, that works. Okay, you can see in this case, I've written the same problem twice. That's because I want to show you that either way you do this, whichever variable you get rid of on whichever side, it's going to work out just fine. So in this case, I'm going to subtract 6g from each side. Right, and that's going to leave me with, on the left-hand side, -2g. I don't always like to be left with negatives, but it doesn't matter, is equal to, the -2g plus 1 is equal to -39. Right. Then I want to, now I'm back to just having one variable. So I'm going to subtract 1 from both sides. So I'm left with -2g equals -40. Right, now this time I want to divide both sides by -2. Remember, you should always divide by exactly what's with the variable. If it's a negative, you want to divide by a negative because you want to be left with a positive variable. All right, so -2 divided by -2 is 1. So that leaves me with g equals, okay, in this case, I've got -40 divided by -2. So that's going to be +20. 20. All right, so let's take a look over here. All right, now my preference is always to be left with positive variables. So I would probably do it this way if I were just doing it once. But what I want to do is just show you either way you do this, you end up with the same answer. So in this case, I am left with 1 equals 2g minus 39. You can see it looks very similar to the equation that we did before, right? It's just that the variable's on the right this time, but that doesn't matter. I still want to get rid of whatever's on the same side of the equation with the variable. So in this case, I want to get rid of the negative 39 first, and then I'll get rid of the 2. All right, so I'm going to start by adding 39 to both sides. So I end up with 40 equals 2g. All right, same thing. I want to divide both sides by 2. In this case, it's both positive, so I end up with 20 equals g. Right, you will get some picky teachers who, when you're writing your final answer, always want you to put the variable first. So if that's the case, no problem. If 20 equals g, then g equals 20. All right, so you would just switch the order around like that, right? Just, I guess some teachers consider that good form. I don't care if it's written this way or this way. All right, let's take a look at one more because I want you to do some practice problems that involve this one last step here. Sometimes you need to simplify a problem first. And in this case, you can see on both sides of the equation, we need to do some combining of like terms first. So if you look on the left-hand side, you can see you've got a negative 12x and a positive 2x. So let's combine those first. That gives you negative 10x plus 17 equals, right? And then on the right-hand side, you can combine the two constants, negative 20 and positive 3. So when you combine those, you're left with negative 17. And then there's nothing to combine with the 7x, so we'll leave that the same. All right, now we have variables on both sides of the equation. In this case, I'm just going to subtract 7x from both sides. I said I didn't like to work with negatives, but I'm going to force myself to do that just because, you know. All right, so then I have negative 17x plus 17 equals negative 17. How about that? That's pretty cool, huh? All right, then what I want to do is get rid of the 17. So I'm going to subtract 17 from both sides. I'm left with negative 17x equals negative 34. And then when I divide both sides by negative 17, I'm left with x equals 2. I don't know why it capitalizes on me like that all the time. All right, that should make sense too if you're thinking about this over here, right? You got a 17 here, you're going to subtract it, so you got 2 of them. Right, so the correct answer there is x equals 2. And you can plug the 2 back in to see if it works. I'll let you do that on your own. All right, so here's what I'm going to do. I'm going to have you go to Khan Academy to do a few practice problems. But what I'm going to do is I'm going to give you a link to this page. If you want more information on this and maybe taught in a little bit different manner, it might be pretty cool for you to watch some of the Khan Academy videos about solving for variables when they're on both sides of the equation. He approaches it a little bit differently than I do, and I think it's fantastic. Right, but what I'd really like you to do is do these practice problems right here. There are 4 of them, if you wanted to really challenge yourself, try some of these down here. This one has variables on both sides with decimals and fractions. And this one has variables in the denominator. All right, so if you're feeling like you want some fraction practice, do these. Okay, I hope this made sense to you. And hey, nice work on the algebra challenges.